Before we convert anything, I want to slow down on Denary because understanding it properly is what makes binary easy. Denary is base 10. You have 10-digit symbols, 0 through 9, and every position is worth 10 times the 1 to its right. Take the number 3407. The 7 sits in the ones column. The 0 sits in the tens column. The 4 sits in the hundreds column. The 3 sits in the thousands column. Nobody taught you to think of it that way, but that is exactly what you are doing every time you read a number. The value of a digit depends entirely on where it sits, and the columns grow by a factor of the base each time you move left. Written as powers, those columns are 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3. Anything to the power 0 is 1, which is why the rightmost column is always the ones column in every base. Hold on to that, because it is the single fact that transfers. When we move to binary, the columns stop being 1, 10, 100, 1,000 and become 1, 2, 4, 8. But the reason they grow is identical. Each column is the base raised to the position number, counting from 0 on the right. So here is binary. Base 2, which by our rule means exactly 2-digit symbols, 0 and 1, and the columns double as we move left instead of multiplying by 10. Now this is where I want you to be careful because there is a trap. In Denary, a digit can be anything from 0 to 9, so the digit itself carries information. A 7 in the tens column means 7 tens. In binary, the digit is only ever 0 or 1. That means the digit is not telling you how much, it is only telling you whether that column is switched on or off. Reading binary is therefore just adding up the columns that are switched on. For an 8-bit byte, the columns are 100 and 28, 64, 32, 16, 8, 4, 2, 1. I would genuinely recommend memorizing that sequence right to left, doubling each time. 1, 2, 4, 8, 16, 32, 64, 100, and 28. If you know those 8 numbers codes, every conversion question on paper 1 becomes arithmetic you can do without thinking. Students who have to rebuild that row under exam pressure make errors, and worse, they lose time they need elsewhere. Converting binary to denary is the easy direction. Write the place values above the bits, then add up every place value that has a 1 underneath it, and ignore every column with a 0. Let us do this one together, starting from the left. 128. The bit is 0, so we skip it. 64. The bit is 1, so 64 goes in. 32. Also 1, so add 32 and we are on 96. 16. 0, skip. 8. 1 added, and that takes us to 104. 4. 1 added, 108. 2. 0, skip. 1 added, and we finish on 109. So that byte is 109 in denary. That is the whole method. The other direction takes more care. Work from the largest column down, and at each one ask, does this column fit into what I have left? If it fits, write a 1 and subtract it. If it does not, write a 0 and subtract nothing. Let us convert 201, 128. Does that fit into 201? It does, so write a 1 and we are left with 73. 64, does that fit into 73? Yes, write a 1, leaving 9. 32, no, that does not fit into 9, so write a 0. 16, no, write a 0. 8, yes, that fits into 9, write a 1, leaving 1. 4, no. 2, no. 1, yes, write a 1, and we are left with 0, which is how we know we are finished. So 201 is 110010001. Now here is the habit that separates the students who lose marks from the ones who do not. When you have finished, convert your answer straight back the other way. Add up the switched on columns of 110, 0, 1, 0, 0, 1. 128 plus 64 is 192, plus 8 is 200, plus 1 is 201. It matches, so the answer is right. That check takes about 15 seconds and it catches almost every arithmetic slip you could make. Also make sure you have written all 8 bits. If a question asks for an 8-bit answer and you write only 6, you have not answered the question, even when the value is correct. Pad the front with zeros. Finally, maximum values, and this is examined constantly. With 8 bits, every column switched on gives 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which is 255. But 8 bits can represent 256 different values. Both numbers are correct and they are answers to different questions. The count of possible values is 2 to the power of the number of bits. 2 to the 8 is 256. The largest value is 1 less than that, because the counting starts at 0, not 1. 0 is itself one of those 256 values, so 256 possibilities, largest value 255. Read the question carefully and give whichever one it actually asked for.